In this lesson, we're going to begin talking about systems of equations, and there are several methods that we use to solve a system of equations, and we're going to talk about the first method, which is called graphing. Now let's first talk about what a system of equations is. It's a collection of two or more equations with the same set of unknowns. The goal is to find values for each of the unknowns that will satisfy each equation in the system. And we're going to be talking about this concept as we move along through this unit. One of the most important things to know about a system is what a solution to a system of equation is. And a solution is the intersection of two equations. So of course you have those two equations, and when you graph them, wherever they intersect is the solution to the system. Now, we have a little bit of vocabulary to talk about here before we begin graphing. And the first thing I want you to take a look at is that first row where it says the graph of a system. So when you have two equations or a system and you graph them, you can end up with three different outcomes. The first one is the one in blue, and you can see that it has one intersection point, okay? Then if you look at the second one in green, you can see that we have two lines that are right on top of one another. This means that you have infinitely many solutions or infinitely many locations where they intersect each other. And then the last one in red, you can see that we have two parallel lines. And when you have parallel lines, we know that you have the same slope. And we also know that parallel lines never intersect. So this is a situation where you don't have any solutions because the lines never intersect. So those are the three outcomes that you can have when graphing a system of equations. Now let's talk about a little bit of vocabulary. So if you look at the bottom here, we have some vocabulary. And the first that I want you to look at is the vocabulary consistent and inconsistent. Basically, what consistent means is that there is a solution to the system. And inconsistent means that there is not a solution to the system. The other set of vocabulary terms that I want to talk about is dependent and independent. And here's what this means. Let's start with dependent. Dependent means that all points that work in one of the equations also works in the other equation. So basically, we're saying that if the two equations are exactly the same, then this is a dependent system. Independent is when there is exactly one solution, or there's exactly one point that will fit into both of the equations. And basically it creates one intersection point. That means that it's an independent system. And we'll talk about these as we kind of move along here. But looking back up at the chart here, kind of going to the row that says terminology, you can see that the blue graph that I have, not only does it have one solution, but that means that it is independent and consistent. The one that has the two lines on top of one another in green, you can see that this has infinitely many solutions, which means that it's dependent and consistent. And then of course our red parallel lines here, of course it doesn't have any solutions, which means that it is inconsistent. So that's just some terminology that we're going to be talking about. So let's go ahead and begin graphing these systems. Let's look at this first one. This is what a system of equations looks like, and you can see that it's just two equations, and these equations happen to be in slope-intercept form. They could be in another form or no form at all, but we do know that these are right now in slope-intercept form, so that makes them very easy to graph. So let's go ahead and graph the first equation. I'm going to go ahead and graph that by taking my y-intercept and putting that on my graph, and then I'm going to have my slope of -1/2. We learned this last unit, so I'm going to go ahead and plot those points. Okay, once I've plotted the points, I'm going to go ahead and draw a line just like I always would, because this is just a linear equation. Okay, now let's go ahead and graph the second one. I'm going to do the same thing. I'm going to have my y-intercept of -4 and my slope of 3. Alrighty. Okay, once I've graphed that second line, go ahead and draw a line through it just like you did the other one. And we have just graphed the system. And the solution to this system is where the graph crosses or intersects each other, which is right at this location here, which looks like it is at the intersection of 2, 2. So my solution to this system is 2, 2. And because this system has a solution, that means that it is consistent. And since it has exactly one solution, that means that it is independent. So I'm going to go circle those terminologies below. Okay, let's take a look at another one. In this next one, we're going to have to do just a little bit of work. You can see that our two equations are not easy to graph because they're not in slope-intercept form. So if they're not in slope-intercept form, go ahead and take a moment and put them into slope-intercept form. So let me go ahead and begin with this first one, and I'm just going to go ahead and rewrite it right here so you can see my work. I'm going to go ahead and subtract x from both sides, and that will leave me with y equals -x plus 1. Okay, so that is my first equation, and let me just go ahead and while I'm here, let's go ahead and do the other one. So I'm just going to rewrite my second equation, and then I'm just going to spend some time using the skills from last unit just to manipulate this into slope-intercept form. So there we go. And we're going to divide this one by -2. Remember when we do that, that's going to simplify down. We're going to use our little butterfly method here to give us 1/2 x minus 2. So we did have to do a little bit of work on this one just to get to the answer. But now let's go ahead and I'm going to graph this equation and this equation. I'm going to start with the first one. I have a y-intercept of 1 and I have a slope of -1. So I'm going to go ahead and plot all those points on my coordinate plane, make them nice and neat. Okay, and then I'm going to draw a nice line through those points, creating my linear equation. Try to draw it as straight as you can. Okay, let's go ahead and draw the second one. I have a y-intercept of -2, and I have a slope of 1/2. So I'm going to go ahead and continue that pattern with my slope. And then I'm going to go ahead and I'm going to connect those points. There we have it. All right, so now that we have done that, let's go ahead and find the solution. It looks like the solution is right here. That's where they intersect. And it looks like that solution is at 2, -1. So this is the solution to my system. And because this system has exactly, well, actually, because it has an answer, it is consistent. And because it has exactly one answer and not many answers, it is independent as well. Okay, now that we've looked at these two general examples of how to graph a system of equations, let's look at some different ones. All right, these are going to yield us some different answers. So let's take a look at the first one. So here's our system. I'm going to go ahead and just, I see that they're in slope-intercept form, so I'm going to begin by graphing the first one. So my y-intercept is -1, and I have a slope of 3/4, so I'm going to go ahead and draw that in. There it is. Okay, I'm going to go ahead and draw my line in. That's my linear equation. And I'm going to go ahead and do the other one as well. The second one has a y-intercept of 3, and it looks like it has the same y-intercept, not y-intercept, I'm sorry, slope. There we go. I can only fit 2 on this one. Okay. So you can see that they look like, the lines look like they're parallel, and they are because remember what we learned last unit, when you have equations with the same slope, that means that the two lines are parallel. So these indeed are parallel, and when you have parallel lines, that means that they're never going to intersect. And that's going to yield us an answer of no solution. Okay, since these are no solution, that means that we don't have an answer, and there's not a solution to the system, which makes this inconsistent. And when a system is inconsistent, it cannot be independent or dependent. It can't be either one because there's no solution. So I'm not even going to circle anything in the bottom two. Okay, let's look at this last one. You can see that this one is not in slope-intercept form. So let's go ahead and just take a moment to do that. I'm going to go ahead and just write this up here and do a little bit of work, a little bit of prep work before we begin. I'm going to divide this first one by 3 to give me y equals negative x minus 1. So that's the first equation I'm going to graph. And then the second one, it looks a little weird. I'm just going to go ahead and rearrange these. If you can see, y is by itself already, so I'm actually just going to go ahead and move the 1 over. That's going to leave me with negative x minus 1 is equal to y, which I can actually just turn around, right? I can just turn this into y equals negative x minus 1. I just flip-flop their positions. So just looking at the equations, you can see they're exactly the same. So this is going to give us one line. Let's go ahead and graph that line. So I have negative 1, and then of course I have a slope of negative 1 as well. So I'm going to go ahead and graph those points in there. And I'm going to draw my line. And you don't need to draw two on top of one another. One will be just fine. It represents that you have two lines there. You're just going to represent it one time. So the answer to this is, well, remember what a solution to a system is. A solution is where they intersect. And these two graphs intersect an infinite number of times. Every single little point on that line is where they intersect. So the way that we indicate this answer is we write IMS. That means infinitely many solutions. And since it has a solution, it has many, it's consistent. And since it has many, many answers, it cannot be independent. It's going to be dependent. So that's how we're going to recognize that vocabulary. So those are the different types of systems that you'll encounter. I do want to take a look at one more thing, and it's just kind of going backwards. So here we're actually given a graph, and we want to figure out what is the system that is represented. So looking at these two lines here, let's go ahead and let's just go ahead and begin with this one in blue. And let's go ahead and determine what the system is. So it looks like I need a slope-intercept form of my line. So it looks like that's going to be y equals, I see my y-intercept is 2, and it looks like I have a slope of 2. So 2x plus 2, that will be the line that I have indicated by blue. And then I'll do the other one in orange, this one right here. I'm going to go ahead and write y equals, and I have to figure out what my y-intercept and my slope is. I see my y-intercept is negative 3, and it looks like my slope is negative 1/2. So negative 1/2 x minus 3. And this right here is the system, your system of equations. Now, it doesn't ask us what the solution is because we could easily identify that just by looking at the graph, but what this question wanted was the actual system, and that's what you see here with these two equations. Let's do one more of these. I'm going to go ahead and change my color back to blue. Let's go ahead and start with this one right here. Remember how to graph this one? This one's kind of a unique one. This one is going to be y is equal to 4. That's the equation, and that's the equation in slope-intercept form. And then if you go ahead and grab the other one as well, I'm going to go ahead and do this one in orange. Looks like my y-intercept is at 1. And it looks like, let's see what my slope is here. It looks like it's negative 3. So y equals negative 3x plus 1. And there you have it. There is your system of equations that generates this graph that you see here. So we went forwards, we went backwards, and we talked about some vocabulary today. But that brings us to the end of our lesson on how to graph a system of equations.